I'll also upload this onto YouTube. Okay. They'll have some sort of questions. ATP, that's why we're doing it, salt analysis. एक दो question आ ही जाता है.
Effervescence is the bubbles in the liquid.
Yeah. So can you give me a reaction which would produce effervescence? So one thing you want to note is when you're talking about all these things, you have to talk about, and I emphasize this with Ira and Soha personally. I think I remember looking at their faces and just going, talk about these things in a way where you're actually present in the lab and you're explaining it to someone who doesn't know chemistry. You know, your friends in economics or never studied chemistry is like, "Mujhe to nahi pata," and you're like, you know, that's how you have to think and talk about it. Fatma says, adding dilute acid to what? I'll say she's talking about a metal. To a carbonate? Okay. Okay. Now, of course, adding dilute solution to a carbonate, so इस तरीके से होगा. Carbonate, I'm assuming it's dry. It's going to be a dry powder. And when we say carbonate, we don't care about what cation is connected to the, क्या बोलते हैं? Carbonate ion. So I'm just trying to focus on. Soha, what if I'm the person who doesn't know chemistry in the lab? That's not too difficult, Soha. What I would strongly recommend from everyone is once you're done, I'll try to share some videos, but just look at precipitation reactions. वगैरह वो बहुत 7-7 minute की videos हैं, and just see what's going on. एक दो बार देखोगे, you'll be like, oh, you know, some things are so obvious, people just don't mix it up. Like carbonate ka test, carbon dioxide ka test, no one mix it up because the words are so unique for it. Turns lime water milky. If you think about it, what does that really mean? It's just a precipitation reaction, if you guys know what that means. Anyway, let me continue with this and look at so carbonate, I'm assuming Fatma is thinking powdered form mein humne dal diya. So this is my powdered form carbonate, and you add dilute acid to it. Dilute acid means it's aqueous. So it's gonna fill this with a colorless liquid. It's going to be a colorless liquid with very likely a white powder at the bottom. The acid will start eating the carbonate away and start producing a gas that's insoluble, that's produced out of it will show bubbles. And that's what we mean by effervescence. Bubbles normally हम बोलते हैं जब पानी बॉयल हो रहा होता है तो बबल्स होते हैं. यहाँ पे बहुत तेजी से करके ना निकल रहे होते हैं. So you use the word effervescence to be more accurate. But if you say bubbles, that's completely fine. Okay? Because one thing to note is when you say dilute acid, to us, dilute acid may be something completely different to, let's say, someone who works in the chemical industry and is exposed to a lot of strong acids. You know, for someone, because it's such a subjective term, dilute acid, dilute HCl for someone in the chemical industry might be 1 mole per decimeter cube because he's used to dealing with a lot of concentrated acid. For us, dilute acid might be 0.05 moles per decimeter cube. And for both of us, when we say dilute acid, we'll get different reactions if they put this acid or this acid. What I'm trying to say is they haven't given us the concentration. So if two people are trying to think, yeah, dilute mere liye to ye hai, experiment kar liya, some might have slow bubbles, other people might have a little faster bubbles depending on your understanding of dilute. Does that make sense to people? And the reason they do this, no, you write dilute, but it doesn't matter. You can just write acid for this particular case. Yeah, just add NaOH. If you look at the marking schemes, they barely highlight dilute. And when they do highlight it, it's not like it's not going to work. Like carbonate, if you add a strong acid, it's not like it's not going to work. Dilute acid, they just use it because वो फट के बाहर ना निकल जाए, you know, that's why they're emphasizing on the dilute. So dilute is not necessary to write. ठीक है? But aqueous is necessary. If you write HCl, you know, I would like aqueous means like, okay, yeah, fine. We'll get to that when we get there. Okay. Let's say there's now if you know, carbonates also produce a lot of carbon dioxide. When you heat it, right? So will we say TK? Will we say this produces a lot of effervescence as well? Will this produce a lot of effervescence as well? Fatma says no. Other people, what do they say? Ashwin, what do you think? Soha? Fahad? Sab baatein kar rahe hain, like everyone's fine, and I ask one question, everyone's like pin drop silence.
Fizzing.
My question is, this is carbonate. If you heat it, also produces a lot of carbon dioxide, much like a carbonate in an acid. Will this produce effervescence is my question. Will you say?
No.
No, sir,
right?
because they are
Why?
not bubbles.
Why are there no bubbles if carbon dioxide is being produced?
सर क्योंकि CO2 रिलीज हो रही है.
Yeah?
It is going in the air. That's why.
Because it goes in the air. Because how do you see a colorless gas? You can't. So if it's over here, you won't see anything. But if the gas was colored, you might see, green gas evolved or something, right? But it's completely colorless. You can't identify, you can't tell if carbon dioxide was involved. At worst, you can see probably the mass of this thing decreases. Why do I say it like that? Because calcium carbonate is white in color and calcium oxide is white in color as well. But when it gives off carbon dioxide, you don't see this given off. So you just see, oh, the mass is, it looks like it's just getting thoda sa chota. But in a small piece, you can't really tell too well. Okay, does this make sense? You guys understand when you will see an effervescence versus when you'll not see an effervescence? Okay, I think everyone gets it. What is a precipitate? PPT, what is it? What do you guys understand by precipitate? Aisha, how about you? Oh.
It's the solid substance left after reaction.
Solid substance, you broke up a bit, but like some sort of solid substance. Okay. Anyone else? Color change. Fatma says color change. Okay. Anyone else? Anyone? Any? Ashwin is very quiet today. Solid residue. Yeah. I think everyone understands it, but to know it is something slightly different. Fahad, Rafael, what say you guys think? Let me know. What do you understand by precipitate? Please be more interactive, guys. Precipitate, it's one of those classes, especially. Even if you don't know, there's no wrong answer. We're doing it for the first time. Precipitate. Okay. Drops. Those words are generally.
Sir, जो बचता है.
जो बचता है? Okay. ठीक है. Okay. What happens is if there's a chemical reaction. Now, in the periodic table, you deal with primarily with group 1 elements, group 2 elements, and group 4, 5, 6, 7, 8. Group 7 elements, especially in identification of ions. Most of these are, in case solutions are colorless. Most. Okay. And their products, like their solid form, is white. Because they're colorless, they're white. What happens is an atom's color is because of their outer electrons, how they behave. We haven't studied it, but that's why certain things have colors, right? So that's me saying it. And that's the same reason because transition elements ke hum orbitals dekhte nahi hai because they're kind of complicated. And those complicated orbitals give transition elements their colors. So transition elements will normally have colors. Meaning by color, I mean they will be non-white. And you can probably think of some colors as copper turning blue solution, Yellow, I can't think of any, but iron has that distinct red rust ka color, you know. Aluminum oxide is not a transition element, so it's white. Uska oxide be grayish white hota hai. Iodine, yes. So iodine is in group 7. So that has a yellowish color, but it's not a transition element. Chromium is bluish green as well. What else? Yeah, I think these are your primary transition elements that are talked about. So they'll have color. Okay. Okay. So they'll probably be colored in a solution as well. And one good example is copper sulfate is bright blue if it's hydrated. It's blue in color. And when you put it in water, when you make a solution, copper sulfate aqueous means that the solution contains only copper 2+ ions and sulfate ions. Sulfate ions are colorless. Copper ions are blue because it's a transition element, or uska color hota hai. Copper has its distinct blue color. I've shown you my copper glasses. When they rust, they form copper ions, right? Copper 2+, and copper 2+ is very distinct blue in color. Okay. So that's one of the things. But a precipitation reaction is, let's go over to a precipitation reaction. I talk about colors because precipitates have distinct colors. If there are two solutions, let's say, can't think of something good. What is, how will I produce that? Hydroxide, sulfate, calcium sulfate, sulfuric acid reacting with, so this is an acid-base reaction, calcium hydroxide to produce calcium sulfate. Okay, an example of a reaction. Okay, now this is an acid-base reaction where sulfuric acid is the acid and calcium hydroxide is a base. Both are colorless. Now, I'm not too sure. I'm assuming calcium sulfate is a solid and insoluble in water. Okay, it's insoluble. I'm just assuming, I think it is, but I'm just letting you guys know. So how would this reaction take place? You take two solutions and mix them in a test tube, right? This is what you'll see. Two colorless solutions, literally you'll see, आप दो पानी मिला रहे हैं into a test tube, one's the acid, one's the base. And it fills up and the reaction takes place. And if a solid is being formed, this solid is white in color because this is group 2. It's just white. Okay. So what's going to happen is, जहां molecules react कर रहे हैं इसके अंदर, वहां पे एक solid calcium वो हो जाएगा, form हो जाएगा. ठीक है. Now, because they're very tiny, they're floating around. And what you end up seeing is the transparent liquid all of a sudden turns milky or opaque. Do you guys understand what opaque means? Not transparent. You can't see through it. All of a sudden, white fog shows up and you can't see through it. They're tiny dots of solids forming. And if you leave it for an hour or two, just like that, if the solid is heavier than water, it'll settle niche. And if it's less dense than water, the precipitate will rise to the top, leaving a colorless solution thoda niche se, you know. And so if it's on top or at the bottom, we don't really care. But some people get confused. Yeah, ye upar ja raha, niche ja raha, maybe one's a precipitate, the other is not a precipitate. No, they're all precipitates. Depending on their density, they'll either same go to the top or maybe never differentiate. Chloride वगैरह के precipitates will never, you know, differentiate नहीं होते. Like they don't rise or fall. They just stay kind of, you know, opaque. The entire thing just looks opaque. Does this make sense so far? Do we understand what a precipitation reaction is? It's just a solid forming. Precipitate is literally a solid. Now a reaction, how this takes place, छोटे-छोटे dots बन जाते हैं, so it looks like it's fogging up. The solution very distinctly looks like it fogs up. And the precipitate can have a color depending on if it's a transition metal or not a transition element forming the precipitate. ठीक है? You guys got it? Brilliant. ठीक है. Now, why I say jargon, यहाँ पे थोड़ी वो है, you could have just said easily chemistry would have been like, this would have been 10% easier for everyone, ATPs in precipitation reactions, if they just call it a solid is formed, but they had to be fancy and they say precipitate. But anytime you hear the word precipitate, just understand a solid is being formed. And if it looks different from a regular solid being formed, or a regular solid like salt in your, you know, table salt in your, what do you call it? What do you call that thing? Cupboard. It's a solid, but you don't call it a precipitate. But, you know, like precipitate has a definite description. Okay, tiny little solid, it just looks like the solution is turning opaque, right? So that's what they're trying to highlight. And I think everyone got it. So let's move on. Precipitate. When I mentioned the word precipitate for the first time, Ahmed Raza said, "Sir, wo pasine ko kehte hain na?" So can it be bigger blocks? It doesn't really make blocks, because kya hota hai? If I really zoom into the test tube, like this is my test tube, kya hota hai? The solution is mixed na. Har calcium ion jab sulfate ion se randomly milta hai, it turns into calcium sulfate and forms a solid and undissolves in that solution right there, right? So ये छोटे-छोटे pieces बनते हैं हमेशा, you know, and you can force it concentration high करके, you know, that's why they keep it dilute as well. But concentration high करके सब करके force करके बना सकते हैं, ऐसा तो नहीं, impossibility नहीं है. But you won't see blocks so like block, like a bigger chunk of it forming. If you filter the water out, it'll still be powdery, I think. Then you have to do something to it, maybe. Then it'll turn into one giant chunk. But generally you see very powdery sort of thing. So think of it this way: if you take the water out, filter it, and leave it to dry, you'll have a very powdery namak-like substance. But the namak, when I say, is kala namak, right? Like not the granules you get. I think they're formed in a certain way because they're very sharp, distinct salt, what do you call it? Pieces, particles. Okay. This is done. Now I wanted to, my computer's freezing. Great. Any questions so far? Please ask. I say this because my computer started freezing. No, so far? Okay. Got it, got it, got it. Got it. Got it. Oh, yeah. Give me 2 minutes. My computer is indeed heating up. I'm sorry about this. Stopping video for a second because I think that's to blame. Oh, we're doing identification of ions. Nice. That's a good question. I am not fasting. I am well. I'm just not fasting because my health has been suffering a lot recently, and I don't want to task my body anymore. I want to exercise daily, eat well, sleep well, that sort of thing. So I'm in a rhythm because I've been doing 3 jobs, and you know, you've seen me tired or with like a wristband, or you know, like it just gets so much in the way. So not that I can't fast, but I'll be very destroyed by the end of Ramzan if I fast. Recovering from it is just too much. I think we're back. Let me just share this. Sorry, I was drinking. I completely forgot. But I need something. Yeah. Okay. So it's not like I'm sick. I'm just a weak guy. And I work a lot, though, you know. I just want to have more exercise and more time to eat. I can't. Yeah, one of those things. My priorities currently are like, somewhere else. Not that I'm saying it's right or wrong. I'm just saying, like, I personally. Yeah. अच्छा, मुझे क्या चाहिए? Okay. Okay, the first thing we have to kind of filter through is, what time is it? Oh, we have time. I hope you guys are kind of entertained so far. ठीक है. Ashwin kind of knows I work hard because like, I think any advertisement we do, Ashwin is always there. He's on Kohli, he's on, I don't know, he added me on Instagram. I didn't know Ashwin at that time. When he added me, he was the first to add me. So normally I don't add students, but I didn't know Ashwin was my student at that time. So I added him and I was like, oh, I shouldn't have added him. Then I couldn't unadd him. Yeah, very entertained? Okay, that's good. Okay, let's continue. But Ashwin is everywhere. He's sharing my posts, this and that. Thank you, Ashwin. Okay, the first thing. We do are gases. So how do we identify hydrogen? Now, sometimes what exam does is they'll differentiate between what the test is and what the result is. Normally we say hydrogen ka kya test hai? Relights a glowing splint. But sometimes what they do is they'll separate the two, what the test is and what the result is. I said relights a glowing splint, that's actually oxygen. Test is, what's a good color? Priorities. The test is expose it to a glowing splint. You guys know what a glowing splint is? Someone try explaining it. Someone who has a working microphone, because I think it'll be easier. What's a glowing splint? Fatma will tell. Fatma, you don't have a microphone? I thought you were laughing a bit earlier.
सर वो जो गैस वगैरह डिटेक्ट करने के लिए होता है ना, वो जो ग्लो करने लग जाता
आप लोगों ने घर में कभी अगरबत्ती जलाई है?
है। सर अगरबत्ती क्या होती है?
अगरबत्ती नहीं पता? You haven't seen those long brown sticks that you light when there's like a
Yes.
yeah, right? It's not a candle. It's mombatti is a candle. Mom is wax. Batti I means light, I guess. Yeah, batti, no? Agarbatti is the thing. So if you light it, it catches fire, right? And what you do is you shake it up a bit. So it's just glowing at the tip. It's red hot, but there's no fire. That's what a glowing splint is. So think about this jharu ka tinka nikal liya aapne, the kadak wala jharu, not the phool jharu. आपने तिनका निकाल लिया, उसे जलाया, or matches, you light it, it's on fire for 2 seconds, then you बुझा दिया. So it's red hot for a second. That's a glowing splint. If you expose it to hydrogen, hydrogen is very flammable. It explodes. But in a test tube, there's very little amount of hydrogen. So why are you laughing? Matchstick ka papa? What? Oh, so tell me why you're laughing. Okay. So when you bring, like in a test tube, when you bring it in, it'll explode. Now, because it's very tiny amount of hydrogen, it doesn't explode and go boom. It goes, or it makes a distinct pop noise, right? Very quickly it burns. So the frequency is higher of the explosion. So makes a pop noise, popping noise. So it's literally ऐसी आवाज आती है. Haha, Fatma, I'm laughing at Ash and you, sir. What's the matchstick ka papa?
So he's calling agarbatti matchstick ka papa.
I think the mombatti is, oh, acha, agarbatti, mombatti is the daddy of all battis. Or lantern, I don't know. Okay, segue. Chalo. फिर है हमारे पास oxygen. Now, anything burning is, using oxygen. Burning is different, just literally anything reacting with oxygen. That's what burning is. But if you look around, we have 20% oxygen. So anything trying to burn is actually being suffocated. When you expose it to oxygen, it'll really try to burn. So if you bring a glowing splint close to it, it relights it. Because literally आप आग पे पेट्रोल फेंकने वाली बात, अगर बत्ती को जानते हो, relights glowing splint. ठीक है?
Or will it catch fire?
Yeah, it will. But वो जब तक relight होता है, it's a test tube. You're doing it in a test tube. Reaction डालो, oxygen निकल गए, इस तरीके से. But what place has a lot of oxygen? In places where there's, the atmosphere, I don't think there's any such place. But if there was a place,
Near
airplanes?
Near
Airplanes will,
tree.
say that again, sorry. Say that again. What's this meme called, by the way? The guy doing that thing. But near a tree, no. It's like saying if you're, next to me, I'll have a lot of carbon dioxide around me. That's not true. Like we produce a lot less carbon dioxide than you think. Like it's coming with 20% oxygen. It's a small room, but if I airlock it, I can probably survive 3-4 days in it. So the amount of carbon dioxide or oxygen produced by trees in a certain time is not a lot, but over time they produce a lot. But I don't know, maybe it is there. Because also another thing is 80% of the air or 79% is nitrogen in a closed system, right? And what a tree does is takes carbon dioxide, which is only 1%, and turns it into oxygen, right? So if air is 79% nitrogen, 19% oxygen, and 1% carbon dioxide, it'll just turn this 1% to that 19%, and that'll turn into 20%. So the majority will still be nitrogen, and that's the thing. And that's actually a good thing, because oxygen is a little too dangerous. Having it diluted is really good. Because assume you're on like a plane where it's 100% oxygen. If you light a match, it won't just glow, it'll burn and like bahut heat hogi, because all that reaction will take place immediately. Higher concentration of oxygen. I'm sure there's a video where like there was too much oxygen in some room and they lit something and like dhamaka ho gaya, na? Not dhamaka, that thing would like burn whatever the ignition is, but it can be very dangerous. You don't have 100% oxygen anywhere because it's a risk of fire, right? Okay, moving on. Oxygen. It will relight a glowing cigarette as well. Okay, oxygen, danger, danger. Take care. Carbon dioxide ka test. This is, I feel, the stupidest. It's easy to know, but it's kind of confusing. Pass through lime water. Now, lime water, we don't need to know this, is actually calcium hydroxide. Calcium hydroxide is basic in nature, and carbon dioxide is acidic in nature because it's a non-metal oxide. When you react it through lime water, what it actually does is it forms a precipitate of calcium carbonate, right? And calcium carbonate, because it's insoluble, it forms a precipitate, it's a solid, but you just say turns lime water milky. For this particular precipitation reaction, they just say turns lime water milky. And I don't complain about this because once you hear turns lime water milky, you never forget it. Everyone knows carbon dioxide reaction because I hear you can get high, or it weirds you out if you have too much oxygen. If you have 100% oxygen, it makes you high, or like just chakkar de dega, because too much oxygen at a single time. Getting high is indeed bad. Hayden, welcome. Oh my God, Hayden! What is up? Sir, some people see it here. What? Oh my God! Welcome! I missed you. I thought you were like, not in the city anymore.
सर आपके कमरे में हीलियम है क्या?
No, I'm just weird. I don't know. I'm just excited Hayden is here. Is Brandon there as well? Sir is fangirling? Yeah, definitely. Welcome, Hayden. Okay, let's continue. Sorry for the disruption. Okay, now. Ammonia. And also everyone knows this. Now, damp litmus paper. Damp litmus paper. Damp, actually red litmus paper. Now, I don't know why they say this. I've never used litmus paper in my life. Damp red litmus paper. Because pata kya hota litmus paper ka? If it's lying around in the lab for too long, it just doesn't work anymore because it expires or something. Damp red litmus paper. So in labs, we just almost never use it. Now, I think the chemical on it is reusable, so to speak. Acidic conditions, it will turn red. If it was blue, agar red hoga to red hi rahega, so you don't see a color change, so you don't know. But if it's blue, it'll turn red. And if it's red in alkaline solutions, it'll turn blue, right? So saying bring a damp red litmus paper is key. A lot of people can get away with not saying red, but damp is important. Why? Because ammonia is a gas and it just flies away without, catering to litmus at all. Litmus is technically a chemical coated on paper, right? It's just solid. Now, if you damp it, the ammonia gas evolving can touch the water and dissolve in it, forming ammonium ions, which are alkaline. The gas itself is not alkaline, or like you call it alkaline because as soon as it touches water or anything humid, it'll act as an alkali. And as soon as it touches the damp litmus paper, it dissolves in it. And that damp litmus paper is now coated in an alkali. And the color change happens. It turns from red to blue. You guys understand why it needs to be damp? Turns damp, turns blue. Yes?
Yes.
Okay. How'd this happen? Oh, okay. Uske baad, am I going too slow? You guys are like freaking bored out of your mind. Okay. The reason I'm going slow is I'm adding so much description. It'll just, I'm trying to form neurons in your head. So I'm recovering from you getting excited. I'm still excited. I'm just not showing it. I'm just happy you're here. I thought you hated me. You weren't coming to my classes, like Ahmed. Okay, the other gas I wanted to talk about is chlorine. Chlorine. Okay. Okay. Chlorine. Now we don't study this reaction at all. Chlorine, we think, yeah, chlorine jab usme hota hai, pani mein mix hota hai, it just forms HCl. And that's not true completely. It does form HCl, but what it forms is HOCl as well. Why do I tell you this? We are not supposed to know this, but this is actually bleach. Or actually the OCl ion is bleach. This is actually bleach. And what does bleach do? It bleaches. It discolors most pigments. So chlorine, the test for it is bring damp litmus paper near it. वही बात होगी, chlorine gas is yellowish in color. It'll touch the litmus paper, it'll dissolve in it. But you know, the amount of chlorine you're forming is so little, you can't even tell if it's being formed, but you can tell with the litmus paper test. Bring damp, any colored litmus paper, damp litmus paper to it. And what's gonna happen is it's going to you can say bleaches litmus paper or litmus paper turns white. Okay. And if it's blue litmus paper, you'll actually see it first turning a bit reddish pinkish because that's the HCl acidic nature first touching it. Then the OCl takes over and bleaches the entire thing, turns it white. I am in this fine, I'm just joking. He doesn't need to. Exactly, he's pretty smart, man. Like, he's very smart. Just I don't know if it's hardworking or if he's naturally talented or a bit of both. Again, like I don't know him too well, Walibat, but yeah, like some of the things he's very quick at thinking. I don't know if he's done his homework and comes to class or in class he thinks about it. That's what I wonder most times. Okay, chlorine is done, and we're almost running out of gases. We have NO2, we have SO2, and we have H2O. That's not a gas. Can someone recall how do we test for water? If someone says we drink it, I'm gonna throw a shoe at them. Huh. Okay. Now sulfur dioxide, not that it gets asked too often, will easily turn into sulfur trioxide on exposure to any oxidizing agent. So you can use KMnO4, acidified KMnO4 to it, or potassium dichromate K2Cr2O7, and their necessary color changes. So it'll react with SO2 to turn KMnO4, give you a color change of purple to colorless. And I think the other one is orange to green, if I'm not too wrong. Otherwise, it's green to orange. I think it's orange to green. Orange to green, pretty sure. Okay. NO2, what's NO2? No, I think NO2 we don't care about, sorry. But NO2, I want to tell everyone that it has a very distinct brown color. Very poisonous gas, if you recall from our talks in atmosphere. Brown gas. Extremely toxic. That's why we don't have tests for this in the lab, because it's dangerous. Nitrate ion turns it colorless. What's the test for water? Anhydrous, drop it in anhydrous copper sulfate. Anhydrous copper sulfate is white in color. As soon as you add water to it, it'll turn bright blue. We've seen this reaction. I've shown you pictures, if you guys recall. Turns it blue. Now you might see other things written here, but the key is the copper ion. It could be copper chloride even, copper anything. Let's see what this says. Cobalt, they're saying, but yeah, copper sulfate, if you mention it, that's fine. You can drink it because there's a strong risk. What if it's not water? Then you're, shart har gaya aap, zindagi ki, or at least you're gonna have a bad time. Not gonna have iftar for a few days, or not gonna enjoy iftar for a few days. Okay. Okay, understood? Everyone got it? Now this is important because some of these reactions are used to identify Other elements, right? If you want to test for a metal, you react any metal with an acid and hydrogen is definitely given off and you test for the hydrogen, right? And if you're confirmed hydrogen is given off by that noise, you know you reacted it with a metal. If that makes sense to you guys. Okay. Carbon dioxide, if you put acid to it and that liquid precipitates in lime water or turns lime water milky, you know you've reacted an acid with a carbonate and nothing else, because nothing else will give carbon dioxide, or nothing in the lab at least. Okay. Ammonia, nitrate ions, NO3 minus ions, if you heat it with sodium hydroxide and aluminum, a certain reaction takes place where ammonia is given off. Because you can't have nitrogen dioxide coming off because it's poisonous. You might get poisoned, right? So it's dangerous. So what they do is they make sure ammonia is evolved and they test for the ammonia, which is not that great for your health either, but it's safer than, it's not poisonous. The alkaline gas is produced, which will turn damp litmus paper blue, and you know the nitrate ion is there. So essentially that's what we're doing. A lot of these things are either precipitation reactions or test for gases, which we'll do in our next class. Our next class is going to be on Tuesday, 3 to 4. This is the schedule I'm going to follow. 3 to 4 p.m. every day. We'll have 40-minute classes, 40 to 45 minutes, and I'll hang around for extra bit if you guys have questions. Friday go, optional office hours. You guys come to me with questions. I'll try to sort your issues. Whatever you guys want. Okay. Is that clear with everyone? You guys are welcome. Welcome, Ashwin. Ashwin's ready to run away. He's not even fasting. Huh, Ashwin?
Thank you, sir.
Bye, Aisha. I hope you guys learned a lot. And
Thank you, sir. Take care.
bye. You guys as
Bye.
well. Bye-bye. Bye-bye. Take care, guys.
Bye, sir.
Bye-bye. You too, Hayden. Bye-bye. Jawad, welcome. But bye-bye.
सर जा सकते हैं?
Allah Hafiz. Bye-bye. Bye-bye. Unless you have a question, you can. I'm sticking around for a bit.
सर तो क्लास खत्म.
Class khatam. Bye-bye, guys. Take care.
Okay, sir. Have a good day.
You too. You too.